Hello everyone, good evening.
Hello, sir.
Good evening, sir.
Good evening, sir.
Evening, sir.
Evening, sir.
Okay, so today we have session for week 7. Okay. Firstly, are you all clear with permutation combination like till week 6? But you are able to do it?
Yes, sir.
Yes, sir.
Sir, graded assignment.
Yeah, graded assignment 6 we will discuss today. Okay. How many of you started week 7?
Not yet, sir.
Not yet.
Started.
Started.
Okay, so first let's discuss the graded assignment 6 and then we'll move on to week 7 activities. Okay. Okay, so this question, were you all able to do it?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Sir, I have
Yeah.
a question. Sir, first question, is it necessary to, is it compulsory to attend that question?
No, it's up to you. It's of 0 points only.
Yeah, because sir, what happened last time, there was a question in question number 7. Week 4, I guess. So in there, one question was there, like 0 points was there. So I have attempted that question, but it was a wrong question. Okay, 0 point was there of that question. Okay, and after that, when the marks, all the questions are answers are right except that one 0 point, which consisting of a 0 point marks. But when I saw the marks, it was showing 95% instead of 100. It was showing 95.
This term, or you're talking about the previous term?
No, I'm
GA5.
talking week 4 or something like that.
GA5. I actually passed because of that answering that question.
GA5. Okay, this one, right? This question you are talking about. This term's graded assignment 5.
No. It consisting 1 point, sir. It was 0 points, sir.
Previously on the day of submission, it was 0 point. Now maybe it is 1 point.
Okay. So you are saying that you haven't attempted that question because it was of 0 point, and after that it has become 1 point. Is it something like that?
Yes, sir.
Graded assignment for first.
Yeah. Earlier it was of 0 points. Okay, we are looking at it. We will resolve that issue. Okay?
Yeah,
It's
because
under progress for now. Yeah.
because when I saw the score, it was showing 95 marks. Instead of 100. So that is the
Yeah.
reason.
The discussion is going on. We'll come on to some resolution for this.
Okay, sir.
Okay, so here the first question was just about gathering the data. So it's up to you if you want to share or not. Something else. Okay, moving forward. Third question. Were you able to do it?
Yes, sir.
No.
No, sir.
No, sir.
So
Sir,
he's speaking.
No, sir.
Okay, where did you struggle in this?
Sir, I got half.
Sir, we have to.
I got also half of this answer.
Sir, we have to consider both Chennai and Assam also.
Yeah, you have to consider.
Okay, sir.
Because there are, okay, but my question state is, it's saying that there is Chennai and there is a station Assam, and there are 5 stations in between them, right?
Yes, sir.
Station 1, station 2, station 3. So in general, now I have total of 7 stations, right? Now in how many tickets are need to be printed so I can travel from any station to any other station?
7C2.
7C2. Why 7C2? Because order here. Okay, firstly, does the order matter here or not?
no.
No, sir.
No, sir.
Why no?
Irrespective direction of travel is
True and
given in the
so.
question, sir.
No. Irrespective of direction of travel means you have to consider both the directions. It is not only you are going from Chennai to Assam.
Sir, but if a
It can
person
be
take
either
a
way as
ticket
well.
from Chennai to S1, or if it is applicable for both sides, if it is going from
No, if
S1 to Chennai.
ticket is from Chennai to Assam and ticket from Assam to Chennai is different.
So, but irrespective means direction has not to be considered. Irrespective, what is the meaning of irrespective? The direction has not to be considered. So we have to consider only one. If two stations are there, we have to consider that only as one.
No,
What does
irrespective of
irrespective
direction
mean?
of travel here means that the travel of the train, you don't have to consider it's going from Chennai to Assam only. It can be Assam to Chennai as well.
So that interpretation was confusing because I saw the dictionary meaning of irrespective also. In that
Yeah,
it was
dictionary
saying that
meaning is irrespective is yeah. So here, irrespective of
not
direction means train we are referring to.
irrespective means not taking in the direction into consideration. That's what
Yeah.
I inferred. And so
Yeah.
I did not multiply it by 2. But actually in the correct answer, it was multiplication by 2.
No, in
So
that
that
correct
is
answer is permutation. If order is there, then we have to take permutation in that case.
See, why will order be there? Because if someone going from Chennai to Assam or Assam to Chennai, these two
It
will
will
be
be two
different.
different then.
And irrespective of direction means you don't have to consider train is going from Chennai to Assam only. It can be either direction. So that's what irrespective of direction here states.
Got it, sir.
So here order of traveling, direction of traveling will matter. So you have to take in the order here as well. So it will be 7P2. Okay.
Got it.
there was an issue in the interpretation of the word irrespective. I interpreted irrespective as direction as not to be considered. So I entered as combination, whereas actually it was permutation. That was it.
Okay. Okay. Now is it clear or still you are having doubt in it?
So it would have been better if it would have been elaborated that a train from Chennai to Assam is different from the train from Assam to Chennai. If such a statement would have been put, then maybe I would not have got a wrong answer.
So for this reason, only irrespective of direction was mentioned.
So, but irrespective means direction has not to be taken into consideration. That's what I interpreted, sir.
But sir, there is one video in which ma'am has given the example of that circle and then 2 points, and then she has said that the direction, if it is not considered, then it is a combination, whether it is one direction or bi-direction. So taking that as an accord, we can say,
Oh, that's the circular permutation thing. Correct.
yeah, but if we build an analogy of that, they're moving from one point to other point, then
Okay. Okay. If I remember, this was the question, right? This is the number of pods you can make is NC2.
yeah,
But if you make a direction over there,
then it
would
is a
be
combination.
NP2, right?
Right.
Yeah. So here that's what. So for printing the tickets, you need to take into consideration the direction, right? Whether you're traveling from Chennai to S1 or you're traveling from S1 to Chennai. So here the tickets will be different. Irrespective of direction means it was talking about in terms of train, whether the train is going from this station to this station or this station to this station. So you have to consider the both actually.
Okay.
Sir?
Yeah.
So what I did is I did combination NC2 then into multiplied by 2. But if this question comes in EMQ, will it be permutation or combination, sir?
It will be permutation.
In
general,
question
permutation involves combination. See, when you are doing 7C2 into 2, right?
Yes,
if
sir.
you simplify it, it will be.
Yes, sir, it is NP2. 7P2.
So what happens?
But if this question comes in EMQ type, I will be confused, sir, to opt for permutation or combination.
Okay, see, what happens is permutation is, okay, suppose I have 10 objects, okay? And I have to arrange them in 5 places. Okay. So first, what I will do is one way to think of is that one approach you can take. First, I will select 5 of these 10 objects, right? Because I only have 5 places to fill.
Yes, sir. 10C5.
10C5, right? Then I will arrange them, right? Right?
Yes,
So
sir.
at the end, I am doing the arrangement. I'm just splitting this arrangement into 2 parts.
Okay, sir. Okay.
If I am only doing the selection thing, it would be combination. But after selecting, if I am doing the arrangement, it would be permutation, right?
Okay, sir. Okay.
So that's how you can identify any MQs.
Okay. Thank you, sir.
Here also you selected 2 stations and then you arrange them. It either can be at first place and either could be at second place, right?
Yes, sir. Got it, sir. Thank you, sir.
So just a request, can you take this as a feedback? I mean, just to make it more clear, could you just add that a train from Chennai to Assam is not the same as train from Assam to Chennai? If you could
Yeah,
do
we will discuss it. Okay. If
because I
possible,
would not
we
have
will-
got it wrong if because because of the word irrespective, I did not
Yes, sir.
consider it
Yes, sir. Irrespective word is a confusing here.
Okay. We will have an internal discussion on it, but according to me, it should be clear. But yeah, we will take a note of it. Okay. And if we find it to be ambiguous, we will look into it as well. Okay.
Sir,
Okay. Did
excuse me,
anyone?
sir.
Yeah.
Sir, could you please repeat what you explained about the circular permutation on your notepad? Like you said something about circular permutations, right?
Yeah.
When you, could you please repeat that part? I did not hear it. Like, what was this?
Okay. So I think someone was referring to the ma'am's lecture in which ma'am explained that suppose it is a circle, right? And there are n points in a circle. Okay. Then how many chords you can make? For chord is just a straight line you can draw using the 2 points. Okay. So in general, you have to use 2 points to make a line, right?
Yes.
It could be any 2 points of these. So using any 2 points, I can make a line. So in total, I can make NC 2 lines, right?
Yes, sir.
But if I assign direction to it, like it is going from A to B, and the line going from B to A, if these 2 lines are different, in that case, it would be NP2 lines.
Okay, got it, sir. Thanks.
So that's what it is. Okay, regarding this question, how many of you struggle to understand it? Can you just raise your hand in the Zoom chat so I can see? Okay. Okay, noted. Okay, thank you guys. Okay, moving further. Okay, question number 4.
Yes, sir.
Were you all able to do it or?
No.
Done, sir.
Okay, how did you approach this one? Anyone want to share?
And
like,
we
Yes,
we
sir.
took
So
total
what
and
I did
minus
was-
together. We
Yes,
took
sir. What I
total
did
and then
was-
we minus when we if these two are coming together
Yes,
and
I did.
minus from the total. If
So I
all
did
are
the
coming
same.
14C6 minus taking 2 together. Then
Okay.
In my
became-
case, the data was 11 friends.
someone who was not able to do it, how did you approach it? Like who struggled in this question?
Sir,
Okay, how did you approach it?
So I first took a case where a person A attends a party and person B does not. and a case where person B attends it and person A does not, and a case where both of them don't attend the party, and a case, yeah, that's it.
Okay, these are the three cases you have taken, right?
Yes, sir.
Yeah, that's okay. So how many cases for this one when A attends and B? Okay, what was your numbers like? How many group of friends and how many are to be invited?
5 and 15.
Okay, total 15 friends, of which 5 are to be invited, right?
Yes, sir.
Okay, so how many ways for the first case when A attends and B doesn't?
So 14C5.
14C5. Okay, why 14C5?
Because out of the 15, B will not attend.
Okay, B will not attend. Yeah, so you're left with 14. Okay, but A is attending, right?
Yes. Okay, so I'll have to take 13C4.
Yeah, right.
That's where I went wrong.
Here again 13C4,
13C4.
and in last case
13C5.
13C5. Yeah, is it clear now?
Yes, sir. Thank you.
But there is an and condition. A and B are not attending the party, right?
A and
So
B
that-
are not attending together.
Yes. So A and B are not okay. So I took only two cases where A and B are attending and where A and B are not attending.
No, A and B are not attending the party together. So it is possible that only A attend and only B attend. Okay.
I don't get that part. Sorry. Could you repeat it again?
Okay. It is mentioned that A and B will not attend the party together, right? If only A is attending the party, then this condition is satisfied. Both are not attending the party together, right?
Oh,
if
okay.
only
In
B
that
is
way. Okay,
attending
in that way.
party, then also the situation is satisfied, right?
So
you have
it's
to take-
either A or B are attending party, right?
Yeah, or both of them not attending the party. 3 cases.
So both together will not attend party, but either one can attend party.
Yeah,
Okay, thanks.
because either condition is nowhere mentioned. It is saying that both will not attend together. It is possible for one of them to go and other not go. Okay, clear with the first 3 questions till now?
Yes, sir.
Okay, this question number 5. I think we have a similar question in solve with us also, right? Okay. Question number 6.
Sir, could you please like explain the question number 5? Cause like I got it wrong.
You got it wrong. Okay. Okay, what's your data set like? What's the days and clothes in your question?
Sir, could you wait? Let me grab my note.
Yeah. Anyone else also struggled in this question or were able to solve it?
Sir, I also struggled.
Struggled,
I
sir.
also struggled.
Sir, I also.
But similar question was also in solve with us, right? If I'm not wrong.
Yes, sir, it was
Yes,
there.
sir.
Okay, so did you guys attended the solve with us session who still struggled in this question?
No, sir.
No, sir.
Okay. Okay. Who was telling the data set?
Sir, I didn't use any formulas. I just used simple logic. I
Yes,
try to
simple
use
logic
logic.
is enough. Yeah.
So I give out the days D1, D2, D3, D4 like that.
4 days.
No, till 5.
Okay, D5.
Till 5. Yes.
Okay.
Let me open up the question again. Wait. Okay, so on first day, on D1, she can wear three. She can wear three clothes, right?
Which ones?
Wait. Okay, excluding the clothes. Wait, excluding the clothes. C1, C1 and C2 can wear remaining others like one C2 and C3.
Okay.
On day 2, she can wear only two clothes. Like if she wore C1 on the first D1, then she could wear C2 and C3 on day D2.
That's how is the question going like, okay. 5 clothes wants to wear even D3 due to some reason C. Okay, such condition will be mentioned, right? C1 must be used either at D3 or D4 or such conditions. Can you read out?
Okay, yes. Okay. Due to some reason, C1 must be used on D3 or at D4, and C2 must be used at D4 or D3.
Okay.
C2 can be worn at D3, D4, and D5, and C1 can be used at D3, D4.
Okay, that's the condition only given, right?
Yes.
And every cloth is to be used at only one day, right?
Yes. There is no repetition allowed.
Yeah. So in total, there were 5 days, and how many clothes are available?
5 clothes.
5
5
clothes. Right?
clothes.
C4, C5, right?
Yes, sir.
Okay. So here, since condition is on the clothes, so I will go clockwise for this. Okay. So if you see first cloth, I can wear on any of the 2 days, right?
Yes, sir.
So first cloth has 2 ways to be worn, right? Either on D3 or on D4, right?
Yes.
Then I come to C2. So
C2 can be worn on 3
in
days.
C2 also I have 2 ways.
Yes.
2 ways, because suppose if I have worn C1 on D3, then for C2 I will have option only D4 or D5, right?
Okay, got it.
If C1 is worn on D4, then for C2 I will have option D3 and D5. So for C2 also I have 2 ways, right?
Yes, sir.
Now 2 of the clothes are done. So C3 I can wear on any of the remaining 3 days, right?
Yes. So 3 into 2
C4,
into 1.
2 days, 1 day. So total number of ways to do it, 24, right?
Sir, how did you conclude that you have to go by clothes, not by days? Like, I don't get that logic part.
Okay, so how I decided is, see, the condition is on the clothes part, right? So that's why
Yes.
I thought it would be easier to do. If I go day wise, okay, suppose I go day wise. So first on D3, see, condition is on D3, right?
Yes.
So I can wear any of the 5 clothes in general. So there would be lot of cases. Suppose you fix D3, C1 and D3, okay?
Yeah, that's where I was so confused, like while deciding D4 and D5.
Yeah, so here you will have a lot of cases to handle. So that's why I switched to the clothes part, because I know the condition are easy on the clothes part. That yeah, first cloth I have 2 ways, second cloth I have 2 ways. For remaining 3, I can find out easily. There are no cases, only one case, right?
Yes, sir. That
So
was a
to
great
avoid
tip.
lot of cases, I have avoided this. So these things comes with, like, more you practice questions on permutation combination, more you will be able to identify like how to deal.
So we should always go by the object which is like to which the condition is applied, right?
Yeah, that's what I prefer generally.
Okay.
So
Thanks.
here the condition is on clothes, I will go by clothes. And also suppose this condition was on C3 and C4, let's suppose, okay? Suppose the condition was on C3 and C4. So in that case, I would first fix C3 and C4. But for C3, I have 2 ways. C4, I have 2 ways. Then I would start filling out C1, C2, and C5. That's also you can do, right?
Yes, sir.
So always try to handle the condition first. Remaining thing you can easily handle. That's the easiest part to go.
If in this question repetition would be allowed, repetition would have been allowed, then what would be the solution?
Repetition would have been allowed. Okay.
Yes,
so what what should be the approach according to you in that case?
I think
this condition is valid, right? C1 and C2.
Yes, sir.
Okay. Okay. Then, yeah, how would you approach in that case of repetition?
She can wear C1 in two ways, either D3 or D4.
Okay.
And for C2,
yeah,
D3 and D4 is also available.
Yeah. So you are saying it would be 2 ways, it would be 3 ways, right?
Yes, sir.
Okay, and then for C3?
For C3, she can wear it at any D3 and D4. 3 ways, sir.
3 ways, but repetition is allowed, right?
Yes, sir.
So any of the 5 days, right?
Okay, yeah, any of the 5 days, yes, sir. 5.
Okay, now one more thing which you forgot in this is, you are saying that C1 I can wear in 2 ways, right?
Yes, sir.
So it is, okay, C1 can be worn only on, must be either at D3 or D4. So C1, 2. Okay, it is also possible that I don't use C1 at all.
What, sir?
There is a possibility that I won't use C1 at all. Like I can also wear C5 on all the 5 days, right?
Yes, sir.
So such cases meaning is missing in this scenario, right?
Yes.
So in case of repetition, what I would do is I would go by days. Okay. On day 1, I can wear any of the 5.
Yeah.
No. See, on day 1, I can wear any of the 4.
Yes, sir.
C1, C2, any of the 3.
No, 3 class, sir.
3. Okay. And on day 2, also I can go with any of the 3. On day 3, I can go with all the 5, right?
Yes, sir.
Because I can also use C1 on D3 and C2 on D3. For D4 also, I can go with all the 5 clothes.
Yes, sir.
And for D5, I can go with 4 clothes, right?
Why 4, sir?
I can use C2 on D5, but not C1. See, what's the condition is C1. Okay, let me just erase it. See, you had 5 clothes in general, right?
Yes, sir.
C1 can only be used on D3 and D4, right?
Yes, sir.
C2 can only be used on D3, D4, and D5.
D5.
Rest all can be used on all the 5 days.
On the 5 days.
Right? So if I go day wise, on the first day, I have option of C3, C4, and C5.
Yeah. 3 ways.
Right? On second day, again I have option of C3, C4, C5. On day 3, these 3 clothes I have, but I also have C1 and C2 for day 3.
Yes, 5 ways.
For D4, again I have these 3 plus C1 and C2 as well.
5 ways.
For day 5, I have these 3 and C2 as well, right?
4 ways. 4 ways. Yes.
So in case of repetition, it would be something like this.
We'll have to go by days in case of repetition.
Yeah, in this case, I will go by days. Because if you go by clothes, you notice where you are struggling, right? Some cases are getting missed out. C1 you are saying can be on 2 days. C2 can be on 3 ways.
3 ways.
5, 5, 5. But we are missing some cases where I won't wear C1 at all and C2 at all.
Yes, sir.
So to handle those cases, I'm doing day wise in that case.
Okay. Thank you. Thank you, sir.
So more you practice, more you will be able to think of like how to approach cloth wise, page wise. Such things will only come with practice.
Okay. Okay.
Okay. Clear with the first 4 questions or any doubt till now? Anyway. Okay, question number 6. Able to do or got stuck in between? Question number 6. Is it clear with everyone?
Yes, sir.
Okay. Question number
Please, sir, please explain question number 6. Please.
Okay. You weren't able to solve it?
I solved it anyhow, but conceptually, I was not able to figure out.
Okay. How did you approach this one? Like how many digit numbers you have to form firstly?
My question, sir. Yes, sir. 19-digit number.
19 digits. Okay. Okay, let's not go with the 19 digit for conceptual. Okay, let's make it 5 digit. Okay.
Okay.
Okay. So first digit, second, third, fourth, and fifth. Okay. So for it to be palindrome, it should read same from start and end, right?
Yes.
So if number is this, it reads same. Either you read from this side or this side, right? You have to form such number, right?
Yes, sir.
So at the first place, you can have any of the numbers from 1 to 9. 9 ways, right?
Okay. Yes, sir.
But the same number should be at the last place also.
That is fixed.
Yeah, so it will be fixed. So as soon as you fix the first digit, your last digit also get fixed, right?
Yes. Sir.
If you fix the 5 here, it will be 5. So only one way for this, right? For the second position, you can have any of the number from 0 to 9. So 10 ways.
10 ways.
But your second number and second last number should be the same. So again, it is fixed by this, right? For the middle one, you can have any of the 10, right?
Okay. Sir, I had problem for middle digit only, for middle one.
Yeah, middle one could be anything. It is not related to any other. These two are related, but it is independent. It could have any of this.
Okay.
Right?
Okay.
Sir, can you please explain again? Like, as in my set, it was stating like 9 digits.
Okay.
Then
Okay. How did you approach? Like, how did you start doing this question?
I took like 10 ways first digit.
Okay, first digit you can fill with any number from 1 to 9, right?
I count the zeros.
Okay, so if 0 comes here, it would be a digit number, right?
Understand.
So there are 9 ways. But for it to be palindrome, it should read from this side and this side the same, right? So whatever number you're using at this place should be the number at this place. So there is only one way to fill it, right? Because you can only use the number you are using here. If you are using 1 here, you should use 1 at the last digit also, right?
Yeah.
For second, you can have any of the 0 to 9. So 10 ways, right? But your second last, again, you have 1 way because the number you are using at the second place should be your second last digit as well, right? Same for the third and third last, right? Same for here. And this one, you can have any of them. It is not linked with any other. So you are getting the linkage, what links we are having in between the digits. Is it clear now or you still having doubt?
So like how it counts like 10 to the power 4.
Okay, so for okay, so you're clear with the first step. Like for the first place, we have 9,
Right.
right?
Yeah.
This is clear, right?
Yeah.
And as the digit I am using at the first place should be used also at the last place, right?
Right.
So only one way to fill the last digit, right?
Yeah.
Okay. Now for the second digit, you can use any of the 10, 0 to 9.
Yes.
And the number you are using at the second digit should be your second last digit as well.
Yes.
Right? Now third digit again, you can have any of the 10.
Yes.
And the digit you are using here should be your third last digit, right?
Yeah.
Now the fourth digit which you are filling should be your fourth last, right?
Right.
Now the middle one, it is free. You can have any of the 10. It is not having any linkage with any other digit, right?
Okay.
So 9 ways to fill the one.
Okay.
10 into 10 and then into 1 4 times, right?
Oh, got it.
Okay, it is simultaneous, right?
Yes.
That's why we are multiplying with repetition. That's why we are taking 10 10 every time, and order do matter, right?
Got it.
Number 1 2 3 is different from 3 to 1, so order matters, right? Clear with this?
Yes, sir.
Okay, moving further, this question.
Yes, sir.
It is, I think, same as the first question, but you don't have any condition of divisible by 4 or something, right?
Right.
Okay, question number 8.
It's also okay.
Okay, okay for everyone. You can move forward, right?
Yes, sir.
Okay. Question number 9.
No, it's I stuck the like for me it was wrong.
Okay, so what was the numbers in your case?
Mine was 6 players formed from 14 state level and 18 district level.
14 state and 18 district level, right?
8.
8. Okay.
And such that the group contains exactly one district level player.
Okay. Exactly one district means you need to select 5 state level players, right?
Yes.
And 1 district level players.
Right.
So here, do order matters or not?
No.
No, right? Because in any order I select, I am selecting only these 6 players. So order does not matter, right?
Yes.
Okay. So okay, first let's select the district level player. So in how many ways you can select the district level player?
One only. Oh, means 8C1.
8C1, right?
Yeah.
Now you have to select 5 state level players from these 14. In how many ways can you do it?
14 C5.
C5, right? So that's the answer.
But it got wrong for me.
Okay, I think some computational error. What's your final answer?
Mine was 192190.
We have so we had 8C1, right?
Yes.
And then this was for district level player. Then for state level player, we have
C5.
C5, right? Multiplying that to 16016, right?
I did somewhere mistake.
Okay, maybe some computation error, right? But the concept was right?
Yes.
For question number 10,
So what was the answer to that question,
which question?
which we were solving right now?
16016.
Okay, yeah, got it.
Okay, question number 10.
It's okay.
Able to do, right? Simple, you just have to open and plug in the values.
Yes.
Okay. Question number 11.
No, this was again wrong for me.
Okay, so these properties are covered in lectures as well, right?
The
Yes,
basic
sir.
properties of yes.
Yeah, okay.
So
So you can
option-
also open and check it. Would be like all the three are true. Yeah.
Sir, option B, can you explain, sir, how it is like
Option B, okay, for r equal 0 and r equals n. Okay. Okay, so it's something. NCR. Okay. NCR. You know the formula, right?
Yes. Into R factorial.
Right. So here it is given that r is equals to 0, first condition, right? I think even with this condition, you will be able to, okay, 0 factorial. So it's n factorial upon n factorial, and 0 factorial is 1, right?
Yeah.
It's 1.
Okay. Yes. Actually, I applied both the conditions, so I was little
No, applying
confused.
both will give you the same answer. See, NCR, right?
Yeah.
R
So
is
it will
equals
give
to
same.
0. So both are 0 in general. So 0 factorial.
Yeah.
Right?
Yes.
Why it is written like n greater than 2?
It is for in general, like here the condition is given, right? But wherever conditions of R and N is not given, you have to consider n greater than 2. That's what it actually means. For option 1 and option 3, you have to consider n greater than 2. The part 1, is it clear or any doubt till now?
In this question, NCR.
Okay, 11th one, right?
Yes, sir.
Yeah.
NCR plus NCR minus 1 is equal to n plus 1 CR. I can solve it by breaking it into formula.
Okay.
But madam also told ma'am had explained in the lecture to remember this formula by explaining a concept. First you include one thing, and can you, sir, explain it that way?
Okay,
how to remember this formula? NCR plus NCR minus 1 is equal to n plus 1 CR.
Okay, in general, if you ask, I don't remember any formula. I prefer to solve it. Because if you keep on remembering the formula by the week 12, you will have a lot of formulas to remember. So first thing is to just, easiest one is to just remember it.
Okay.
Which explanation you are referring to? Remember the lecture number?
Actually, yes. No, sir. Right now I'm not remembering which lecture. Actually, ma'am had told, sir, that out of an object, we first suppose that one object is always included.
Okay.
And other case was one is not included.
Okay, one object is always included.
Yes, sir. Out of n, one is always included, and we have to.
One not included always, right?
Yes, sir.
Okay. And one always included. So you have to select R minus 1, right?
Yes, sir.
Sit. And one not always included.
The same object is not included. one object or the same object is not included. In second case, sir. First case, same object is included. In second case, same object is not included.
It would be this, right?
Yes, sir. N
Okay.
minus 1 CR. Yes.
Okay, then.
Here it will be n minus 1, sir, in the first one. One is always
Yeah, n
included.
minus 1. Yeah.
N minus 1. Yes, sir.
Okay, okay. So you're okay. Okay, that approach. Okay.
So in the
Okay,
lecture, she
suppose-
said that suppose A is one object which is included. There can be two ways. Either A is
Yeah.
included or A is not included. So she added both the conditions after
Three.
that.
Yeah. Suppose you have 5 objects, okay?
Yes.
O1, O2, O3, O4, O5. And I have to select, let's say, 3 of it. Okay.
Okay.
Now, see, out of these 5, so what all are the possible? Okay, let's say your focus is main on O2, let's say. Okay. So either O2 will be selected. You can pick any of them. I'm just selecting O2, okay?
Yes.
Or another possibility is O2 is
will
not selected.
be selected.
Right? Okay. These two are the only possibilities, right?
Yes.
So if O2 is selected, it means out of the remaining 4, you have to choose 2, right?
4C2.
If O2 is not selected, it means you out of the remaining 4, you have to choose 3, right?
Yes.
So you have split this into 2 cases and then adding them up, right?
Yes.
Or if you don't split into cases, it would be simply out of 5, you have to select 3.
3.
So that's how you can remember the property.
Okay, okay, sir, got it.
N minus 1 CR plus R gives you NCR, right? This is the property, right? Okay. 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 So we are clear with part 1 now, everyone? Or any doubt in this? Here, let's move to part 2. Okay, part 2, how many of you were able to do?
I did it, sir.
Any doubt in the part 2 part, or is it clear?
Sir, for part 2 solution is not visible.
Or the solution PDF is uploaded, right? Supplementary content, it is available. Week 6 part 2, right?
Okay, okay.
Week 5, week 6, all these solutions are available.
Okay.
Okay. Okay. Any other doubt in week 6 graded assignments? Or shall we move to week 7?
Sir, please discuss last question of this AMQ.
Last
7.
question. Okay. This one, right?
Yes, sir.
Okay, so there are, were you able to do the question 5, 6?
Yes, sir, but I totally score very bad, so I have to check what did wrong.
Okay, so 5, 6 was correct, you were saying, and 7 it got wrong, is it?
Yes, sir.
Okay. Okay, so there are 10 teams in total, right? So in the first round, some matches are happening. So in general, you have to select the 5 teams who will be qualified for the next round.
Yes, sir.
Okay, so if you simplify this question, it is just out of the 10 teams, you need only 5 teams for the second round, right?
Yes, sir.
You have to select, right?
Yes, sir.
So simultaneous occurrence,
Yes, sir.
Okay. Replacement or repetition?
No.
Okay. Order?
Order does not matter.
Okay. Permutation or combination?
Uh, Combination.
Combination, because we are selecting, right?
Yes, sir.
So 10C5, right?
Yes, sir. Yes, sir.
In
Sir,
10C5.
the condition given, the matches given, that
It was
does.
just a story build-up, right? Nothing else. It is written assume that any team can qualify. So that matches being played is just the context of the tournament, nothing else.
Okay, sir.
Sir, here if they specify any particular team, then it will be a arrangement question, right? Or how it is?
Any specified team, like example into this?
Suppose sir, there have mentioned some A to B, some A1, A2, some teams are there, and they
Okay.
tell that from like say suppose two teams A2 and A3 qualifies.
A2 and
Then
A3 qualified. Okay.
so like will be like arrangement, or it will be like
No, it will be still, you are still selecting the 3 teams, right? In total, you need 5 teams of the 10, right? Now you know that 2 teams, these 2 are qualifying. So you are left with 8
3
teams and you need 3 more teams for next round, right?
Yeah, so from 8C3 to 8. Okay, yeah.
So whenever we are doing the selection thing or picking up, so it's only the combination part, right? Whenever we have to make an arrangement, like suppose, okay, let's say the first team I need to give the gold medal, silver medal, and bronze medal. So in that case, it will be an arrangement, right? Because A1 getting gold medal, A2 getting silver, A3 getting bronze. It is different from A3 getting gold and A2 getting silver. But in general, I am selecting 3 teams only for the next round. There is no distinguish between the awards given to them or something. It's the same award they are getting. That is qualification to next round. Right?
Yeah, yes, yeah.
So order doesn't matter in that case. So basically permutation you can identify from the order. Whenever order doesn't matter, it's mostly combination. And in case it order matters, it's mostly permutation. You can notice that in
Sir, what mostly means whenever order matters, it can also be a case of combination. Mostly, you said mostly, not always.
You can consider it always. Like I haven't come up with a case where order matters and it is combination.
Okay.
In future issue come up, so that's something mostly. So it's just a noticeable part. Whenever order doesn't matter, it's combination usually because you are selecting. And in selection, order doesn't matter. At the end, you are selecting only these 5 teams, right? It doesn't matter which team you have selected first or second.
Hello, sir. When we are selecting from a group of, this is not related to this question. When we are selecting, you are saying it's combination. But when we are selecting also, maybe sometimes we select one object first, then the second, then suppose we have to choose 3 objects out of 10. We are not going to select 3 together, right? We'll have to select the first object, then the second object, then the third object. So first object we can select in 10 ways. Second object we can select in 9 ways.
Yeah.
And the third object we can select in 8 ways.
Okay, so yeah, in that case, suppose the first object selected is A, then B, then C. Okay.
Okay.
Or suppose first object selected is B, then A, then C. So you have to decide if order matters or not. If order doesn't matter, then in that case, these 2 are the same cases, right?
Yes.
Because at the end, what you have selected is only A, B, and C.
Yes, yes.
So that's combination. So to come up with this, so see, when you are doing 10 times, 9 times 8, you are considering both the cases as same, right?
So suppose, sir, we have 3 shirts and 3 trousers, and we are going to select 2 objects out of these.
Yeah.
So sir, when we select suppose we select the first one, we
Yeah.
select one out of these six, one out
Yeah.
of these six.
Yeah.
And the second time we can select one out of the remaining five.
Yeah.
So
Okay. Let's come to this. Suppose you have these 4 objects, okay?
Yes.
And you have to select 2.
Yes.
So for first place, you are saying you can have any of the 4, and for second, you can have any of the 3, right?
Yes. Yes.
Okay. So let's make it 3 only. So in that case, it would be 3 times 2, right?
Yes.
So what all are the
This
possible
is a
cases?
permutation. This is a permutation, but
Yeah. So at the selection, see what all are your cases coming here? A, B, A, C, right?
yes.
Or B at first and then A,
Yes.
right? B first, then C, or you can have C first, then A, and C first, then B, right?
Yes. Yes.
So see, in these 2 cases, if you are selecting A first or B first, doesn't
same
matter.
thing,
At the
the
end, you are
same
selecting
thing.
same, right? So 2 cases are same. In this case also, it's the same, right?
Yes. So combination is only 3, permutation is 6.
Yeah. So you have to divide it by 2 factorial. So that's 3.
Yes. Yes.
Right.
But suppose A and B and C are not distinct. Suppose we have 2 objects of A nature and 1 object of, or 2 objects of B nature. Then suppose like 2 shirts or 3 shirts and 3 pants.
Okay, 3 shirts and 2 pants. Okay.
Yes. So first object we can select out of 5, and the second object we have to select out of 4.
Yeah.
So,
but here also, if you select the shirt 1 first or pant 1, or you have selected pant 1 first or shirt 1, it is the same case, right?
yes. Yes.
So that's why again you have to divide by 2 factorial. It would be half.
Okay. Okay.
So whenever order doesn't matter, it's combination. Whenever order matters, it's permutation.
Okay. Okay.
Okay,
Sir,
so
I have
yeah.
one doubt, sir, relating to the questions when repetition is allowed, number of permutation when repetition is allowed.
Yeah.
Sir, I'm basically doubting which one. Actually, the formula is n to the power r. Which one is n and which one is r? Whenever question comes, I got confused.
Okay. Okay, let's consider that cloth example question we did in graded assignment, right?
Yes.
Suppose you have 5 clothes. C1, C2, C3, C4, and C5. And you have to wear it on 3 days. D1, D2, and D3. Okay.
Yes.
And you can wear with repetition, no condition on any of the clothes. Okay.
Yes.
So on the first day, you can wear any of the 5.
Yes, sir.
On the second day, you can wear any of the 5. On the third day, you can wear any of the 5, right?
Yes.
So in general, you can view this question as you have 5 objects, right? And you have to arrange them at 3 places, right?
Yes.
With repetition. So n is your total number of objects, and r is the number of objects you are arranging. Okay. If you are arranging all these 5, it would be 5 raised to the power 5. Here I am arranging only 3, right? So it's 5 cubed.
Okay, so then suppose there is a question: in how many ways 3 prizes can be given away to 7 boys, where each boy is eligible for any of the prizes, and how can we solve it by this?
Yes, and there are 7 boys and 3 prizes,
Yes,
right?
3 prizes.
Okay, 1 prize can be given to only 1 boy, or
No, sir. Each boy is eligible for any of the prizes. Repetition is allowed.
no, each boy is eligible for one of any of the prizes, but what about the prize? Suppose I have prize 1 as, let's say, gold medal, right?
Yes, sir.
So can it be given to all the same multiple boys, or only one will get it?
all, no, sir. I mean to say here, all the boys are eligible for all the 3 prizes.
Yeah, but there must be some condition on prizes as well, right? Suppose, let's assume that one prize can only be given to one boy.
Yes, sir.
So for the first prize can be go to any of the 7 boys. Second prize I have 6 ways, and for the third prize I have 5 ways.
Okay, but here the reputation is not.
Reputation is not allowed because you are not saying that one prize can be given to all the boys.
So, sir, if each boy is eligible for any of the prizes, then can't I solve it by n to the power r method?
No. Each boy is eligible for all the prizes, right? It is fine.
Yes, sir.
But what about the prizes? Can one prize be given to all the boys? Is it possible that one prize?
No, sir.
can be
No, sir.
given
One
to
prize
all
can't. One prize can't be
Yeah,
given to
then
2
it is
boys.
not reputation, right?
Yes, sir.
Because you can give only one prize to one of them.
Okay.
The eligibility criteria is something. Suppose if you say only 5 of them are eligible.
Sir, but I can solve it. First boy can get all the 3 prizes.
Okay, so one boy can get multiple prizes as well.
Yes, sir. Yes, sir.
Okay. Okay. So in that case, it would be 7 times 7 times 7, right?
Yes, sir. 7
in
times,
that case,
7 times.
Yeah, if one can get all, then that's a different case. So there are multiple conditions which you have to take care of, and it will be mentioned in the question as well. As far as I remember, there was a practice question where it was some MLA and one seat can be occupied. One MLA can occupy all the seats, right?
Yes.
It's in this. See, total of 6 MPs, right?
Yes, sir.
The cabinet position can be given to any of these MPs, and an MP can take more than one cabinet position. So here it would be 6 times 6, right?
6 times 6, yes.
So such condition will be mentioned in the question. You have to take care of it.
Okay.
But if this condition was not given, it would be 6 times 5. If an MP can take only one position.
Repetition is not allowed. Yes.
Yeah. Okay. Any doubt till now in week 6, anyone? So shall we move to week 7 now?
Yes, sir.
Okay. Okay, week 7. Okay, till which lecture have you all covered? Like most of you or any of you have covered?
So 4th lecture.
Okay.
Covered all lectures.
All lectures, okay. Okay. Any doubt in activity 7.1 or the concept or explained in lecture 7.1 or something?
So just one question.
Yeah.
So regarding the definition of random experiment, in the
Yeah.
lecture it is mentioned that it is something where the outcome cannot be predicted with certainty. That is
Yeah.
what a random experiment is.
Yeah.
But can we also extend it by saying that for a random experiment, we know all the total outcomes? Like we know what the outcomes will be,
Yeah,
but
that's
we
a
don't know
necessary
which one will
condition.
occur.
Yeah, that's a necessary condition. Yeah. That's how you define sample space for random experiment, right? You must know all the possible outcomes, but you don't know which one will occur when you do it. Like tossing a coin, you know either it will be head or tails, but you don't know which one will occur when you do it.
Okay. Okay. Got it.
Okay, so any doubts in week 7, anyone?
The tutorial 4.
Tutorial 4. This one?
Yes, sir.
37 student joins, okay. 1,000 randomly selected. Okay. Okay, how did you approach this one?
I was trying to select 2 from 100. 100 C2 in denominator. Like that, I was trying to do so.
100 C2? Why 100 C2?
1000 C2.
1000 C2. Okay. Why 1000 C2?
No, sir. 3000 C2, sir.
3000. 30,000 C2 it would be, you're saying.
Yes, sir. 30,000 C2.
Okay.
And on the numerator, and 1000 C1 into 999 C1. Like that, I was trying to do.
Okay. What was the logic behind this?
Out of all possible pairs,
Okay. Total about 30,000 people. Okay.
out of all possible pairs, I'm looking for a particular pair where those two people are in the selected random people. Like,
Okay. But okay. See, in total, I have 30,000 students, right?
yes, sir.
And I'm randomly selecting 1000 peoples.
1000 people.
Right. So what is the probability of any person being selected?
1/3, sir.
1/30.
1/30.
No, it would be 1000 by 30,000, right?
1/30. Yes, sir. 1/30.
1/30. The probability that a student is not selected.
29/1
minus 1/30.
29/30, right?
Yes, sir.
Now the question states that what is the probability that Mary got the feedback form and Asad did not get a feedback form? So probability that Mary got the feedback form is 1/30, right? And Asad didn't get it is 29/30. Right?
Yes, sir.
So that's how you can approach this one.
So in same concept in practice assignment too, sir, I'm facing similar kind of concept. Practice assignment too.
Practice assignment two. Okay. Okay. Which one?
Down, come down. This one, sir.
Yeah.
70%.
Yeah.
So what I did is I took 100 people are there.
Yeah.
Out of 100, 70 completed and 30 didn't complete it.
Okay.
So sixth question, neither complete. Okay, that's 70, 30.
Okay. So probability of completing is 70/100, right?
Yes, sir.
Probability of not completing is 30/100, right? Okay. And okay, now sixth question. Yeah.
What I did is neither of the participants completed the marathon. So
Okay.
those two are coming from those 30 people.
Those two are coming from those 30 people. Okay.
So 30 C2 in the numerator, in the denominator 100 C2, like that I was.
Okay, you are saying in the numerator it's 30 C2 and 100 C2, right?
Yes, sir.
But in the question, I think it's 70%, right? So suppose I have 200 students. You don't know what the number of students. Suppose it's 200. In that case, it would be 200 C2 and
60 C2.
so these are not same, right?
Okay, sir.
The only way to approach is like this. Whenever you know the probabilities, go by that directly. So probability that both will not complete is probability first not complete and probability second not complete, right?
Yes, sir.
I think it will be 0.0.
Okay, sir.
Sir,
Clear?
I
Yeah.
tutorial 2. I think same concept was using the
Where?
tutorial 2.
Tutorial 2. Okay.
In this, they are first selecting the bolt pair of bolt and nuts.
Okay, exactly 3 pairs out of 10 randomly selected pairs are defective. Okay.
But sir, like you discussed now, they are not following that approach. I started doing 8 are defective, so but my answer did go wrong.
Okay, so okay, how did you approach? You were saying out of 200, 8 are defective, right?
Defective. Yes.
Alternately randomly selected 10 pairs. That 3 exactly. Okay, then how did you approach it?
Probability of defected pair is 8 by 200.
Okay.
And correct is 192 by 200.
Okay.
Then I stuck what to do next.
The next you have to make the cases, right?
Yes.
All of all these 10. Which exactly 3 you have to
8 by 200 multiply 8 by 200 like this.
8 by 200 in that. Okay, give me, I think it would be sample of 200 pairs. Okay. Okay. Okay, so defective. Okay. See, I think in this the problem where it comes is you had 200 defectives, right? 200 pairs in general, right?
Yes, sir.
Out of which your 8 are defectives, right?
Yes, sir.
And 192 non-defectives, right?
Yes.
Okay. So as soon as you draw one pair, you will be left with 199 pairs, right?
Yes, sir.
And there the case would come whether the defective is drawn or not defective is drawn.
Okay.
Okay. So such things will get clear in week 10 and 11. We have some easy way to do this question.
Okay.
Okay. But for now here, what you can do is, see, in general, you are selecting 10, right? The
Yes,
total
sir.
ways of selecting is 200 C10, right? Favorable means you have to select 3 defectives.
Yes, sir.
Of these 8. And remaining 7 pieces, you are selecting non-defectives, right?
Yes, sir. So cannot we go by first approach, like we are calculating the defecting probability and non-defecting probability?
Yeah, but here the probability keeps on changing on every draw, right?
Okay, sir. Then we have to consider one nine.
Yeah, suppose a non-defective is drawn here. So probability it would be 8 by 199 into I think some 191 by, right?
Yes, sir.
So similarly for second pair, so there would be a lot of cases as you go on till the 10th.
That's into complexity.
Yeah.
If we allow replacement, then we can.
Yeah, if you allow replacement, then you can do simply.
8 by 200 into 8 by.
Yeah, it would be same. Then you can do.
Okay.
Simply, you have to select the 3 places, right, where you are selecting defectives out of 10. So you choose 3 places of these 10, right? And then probability of defective, and remaining 7 would be not defective, right? Did you get this one or not?
Sir, why 10C3?
Okay, see, you have to select in total 10, right?
Yes, sir.
3, 4, 5, 6, 7, 8, 9, 10. So you can have defective at any of these 3 places,
Yes, sir.
right? So let's say these are the 3 places, or it could be any other, right?
Yes.
And here order of places also doesn't matter. Like if I am getting defective here, it's the same thing. Which defective I am getting here, it doesn't matter, right?
Yes, sir.
So in general, what I am doing is I am selecting 3 places of these 10, right?
Okay, sir. Okay.
Which I can do in 10C3 ways, right?
Okay.
Now the probability of defective is, we know, 8 by 200, right?
Yes, sir.
So 8 by 200 for these 3 places, right?
Yes, sir.
Then for the remaining non-defective, we know it's 192 by 200.
Okay, sir. Got it.
For remaining 7 places, right?
Yes, sir. Okay.
So, sir, here we need to choose that 10C3, or like only defective part will be done if we are choosing it.
Can you repeat?
Sir, you choose that 10C3 right here.
10C3, yeah.
Yeah, without that only if we are like doing defective and this one, right? 8 by 200 into.
Here it would be if you are doing with replacement. Like every pair I'm drawing, I'm putting it back before the next draw. If I am doing without replacement, what would happen is, suppose there are 8 defective and 192 non-defective, right? I draw 1 pair. Now in total, instead of 200, I would have 199. And the probability of defective and non-defective will change depending on which pair I have drawn, right? Suppose I have drawn defective. So in that case, it would be 7 by 199 for defective. For non-defective, it would be, right?
Yes.
So you can do this for only with replacement case. For without replacement case, you have to approach differently. Like in total, I am selecting 10, right? And out of these 8 defective, I need 3. And non-defective, I need 7, right? Is it clear now?
Yeah, yeah.
I think in this tutorial also, the better way would be this one, right? 30,000 1,000 are randomly selected. Okay, so from within 1,000 we are doing that. Okay, that's it. Okay, any doubt in week 7 till now? Anyway?
Sir, in the first activity,
Yeah.
4th question.
4th question, okay.
Sir, the answer is sample space from 2, 3, 4.
Yeah.
Are we taking 2? Is it because the question says 2 consecutive tails after 2 outcomes? We judge the outcomes after 2 consecutive tails.
What should be the answer according to you, firstly?
The first one.
1, 2, 3, 4.
Yeah.
Okay. So here, do you know what the sample space is exactly? Sample space, all the possibilities, right?
Yeah.
And I need to get 2 consecutive tails, right?
Yeah.
So if I am tossing only, you are saying 1, 2, 3, 4, right?
Yeah.
If I am tossing the coin only 1 time, there is no way I can get 2 consecutive tails, right?
Yeah.
So it is not even a possibility to happen.
So we're gonna start it from 2.
Yeah, minimum process I need is 2. Only then I will be able to get 2 consecutive tails, right?
Yeah.
So that's why it's starting from 2.
Sir, in the 6th activity,
Sixth activity.
Fourth question. King and ace cards.
Drawing a king and then ace. Okay.
I didn't get the denominator. Like, how do we choose the denominator? 2 cards from the whole deck.
With the replacement we are doing, right?
Yeah.
Okay. So you have, okay. So in general, there are 52 cards, right?
Yeah.
How many are king and how many are ace?
4.
4 king and 4 ace, right? No
Yeah.
common card. Like one card can't have both king and
No.
ace, right?
Yeah.
Okay. So what's the probability of getting a king?
4 out of 52.
And for ace?
4 out of 52.
Right.
Sir, why did we multiply here? Is this because of replacement?
No, we are drawing one after the other consecutively. The events are independent in general. Okay, the independence thing you will cover mainly in week 8. But see, what's happening in general is, first I'm drawing a king, right?
Yeah.
And then I have to draw an ace, right?
Yeah.
So what is the probability that of drawing a king? It is 4 by
4 out of
52.
52.
Right? Now I have put the king card back.
Yeah.
Right? So, and it's kind of assume you can like simultaneous occurrence, right?
Okay.
Or in other words, what you can do is you can go by simple probability. Total ways of drawing 2 cards with replacement is 52 times 52.
Yeah.
Right? Because it would be
Yeah.
52 C1.
Same choices so far.
Yeah. Then your favorable ways would be first card should be king and second should be ace, right?
Yeah.
So you know the probability formula, simple formula is favorable cases divided by total number of cases, right?
Yeah.
So it's 4 times 4 by the reason why we are multiplying and when we have to multiply and when we don't have to multiply, it would be covered in detail in week 8.
Okay.
But for now, you can just go by simple probability formula.
Okay. In the practice assignment 2, question number 4.
Okay.
I didn't understand how to calculate the singing participants.
Okay, so for such questions, it is better to go with Venn diagram. So
I
have you
went
tried?
with the Venn diagram.
Okay. We'll draw it together. Give me a minute. Okay. So suppose there are 90 students in total, right?
Yeah, 90.
90 students who participated singing, dancing, and acting, right?
Yeah, 3.
Let's say this one is for singing. This one is for dancing, right?
Yeah.
And this one is for acting, right?
Yeah.
Next, the number of students who did not participate in acting or dancing competition are 10.
Yeah.
Okay. So, number of, okay. Let me just use the calculator. So what
So
is the,
can you take dancing, acting, and singing? I took it that way.
okay. Dancing,
acting, and singing.
Okay, so here it is given that the number of students who did not participate in acting or dancing competitions are 10.
Yeah.
So those 10 students are not in this area, right?
Yeah.
And not in this area, right?
Yeah.
So all those 10 students belong to this area, right? Singing.
Yeah, but there can be people who did not participate.
Yeah, but we know that there are total 90 and who have participated. All have participated, it is given, right? All 90.
So how do we find that they all participated?
It's written in the first line of the question, right? You know, total
Yeah, okay,
90
got it.
students have participated, right?
Yeah.
And whenever we are talking now, we are talking about only out of these 90.
Okay.
So we know all this. Okay, so that was the issue we are facing.
Yeah, I thought the union was 90. So there could be some people who didn't participate. So
Okay. No. We are talking about only these 90 students now.
yeah.
I think in the solution also Venn diagram would be available, right?
No, the solution I'll give.
Okay. I think we can check it out. 7. Okay, give me a minute. So, okay, yeah, if you consider the total to be 90, then are you able to do it?
We can't find dance and singing. I didn't
Even,
get out.
even if it's total out of 90, you say.
Yeah.
The screen is not visible.
Yeah, I'm sharing. I'm just looking out for solution. Yes, it's available. Okay, just give me a minute. So you all had this doubt or only one? Okay, so I think let's go statement by statement. Okay. So we know that who don't participate in acting or dancing are 10, right? On the first statement, right?
Yeah.
Then we know that number of students who participated only in dancing. Only in dancing means this area, right?
Yeah, 15.
So we know that this area is 15 students, right?
Yeah.
Okay. The total number of students participated in acting competition are 15.
Yeah.
The total number means it includes all this, right?
Yeah.
So I'm writing it in the square box because it involves others also, right?
Yeah.
Circular box I'm using for alone area like this.
Okay.
Okay, next it is saying that the number of students who participated in both the singing and acting competition are 20. Okay, so both singing and acting means
The intersection and all.
this area, right?
Yeah.
So we know that this is 20. And in the square box because it includes this areas. Next information is given to you is the number of students who participate in both dancing and acting. Both dancing and acting. This area, right?
Yeah, 15.
I'm making it box because it includes this area as well.
Yeah.
The participate of all the three, 10, it is given, right?
Yeah.
So once I know this area, I can also know that it would be 15 minus 10, 5, right?
Yeah.
And it would be 20 minus 10, 10, right?
Yeah.
Okay. So this 50 can also reduce it, right?
25, sir,
25.
25.
25, right? So now we have 15 here, 5 here, 20, 30, 40, 65. Yes. And first part is 10 also we have, right?
Yes,
Did
sir.
not
Not acting or dancing. 10.
10 we also had, right? Only for singing.
Yeah.
That's all right. Total we know 90, right?
Yeah.
So this part we can get by subtraction. It's 50.
90 minus 75.
10, 20, 30, 67, 15, right? So
Yeah.
I think that's the Venn diagram we have.
I got that. Then I can find the probability.
Yeah. Okay. So the first line states that all the 90 are participating. So if such a
Yeah.
case that all are not participating, it could be mentioned. Or the term that have participated would not be mentioned in the question. So from that you can get an idea.
Yeah. Okay. Got it. I got it.
Sir,
Okay.
I have a doubt, sir.
Yeah.
Sir, in activity question 7.4, question number 4, sir.
Question number 4. Okay. Yeah, to the 7.4. Which question?
Sir, question number 4.
Question number 4. Okay, Shabnam has 74% chance of receiving an A in either statistics or mathematics. In either statistics or mathematics. Okay. Okay, so how did you approach it? Simple. Yeah. By this lecture, you are aware of either or statement.
Yes, sir.
Right? You can write it as union of events, right?
Yeah, here it is written that either in a means either in statistics or mathematics, means the statistics union mathematics, right?
Yeah.
So, sir, what to means proceed for this if percentage is given? I think this is a subjective probability. There are 3 types of probability. No?
So let us define event. S be an event at A in statistics, okay? And M be an event at A in mathematics. Okay. So we know that probability of S union M is 74 by 100, which is nothing but 74%, right?
Yeah, correct.
0.74. So I have to find the complement of this, right?
Complement of S union F.
Right? So it is nothing but 1 minus this, right? So at which step did you struggle, like in understanding the statement or the solving?
Understanding the statement, sir, because I confused here by seeing this 74%.
Okay, 74% is means probability of 0.74. Whenever you can write probability as percentage by multiplying by 100. That's what it basically means. If you are saying that 50% chance of happening of something, it means probability is half, right?
Yeah.
1 by 2, 50 by 100, right?
Thanks.
Okay. Anything else? Anyone? Or shall we close for today?
Yes, sir.
Yeah. Okay, guys. Thank you, everyone. Good night.
Thank you, sir. Good night.
Thank you.
Thank you, sir.